Today we're going to talk about how to calculate trigonometric functions of angles of 18, 36, 54, and 72 degrees. I have two videos where I've done it before. One way was purely trigonometric way, the other was geometrical way. If you're interested, the links are below. But here I'm going to do it in a different geometrical way. I'm going to start with a regular pentagon with a side of 1. First of all, let's calculate the angles of the pentagon. We know that in every polygon, the sum of all internal angles is 180 degrees times n minus 2, where n is a number of angles and the sides. In our case, we're dealing with a pentagon, so n equals to 5. And the total sum of angles should be 540 degrees. This pentagon is a regular pentagon, so all angles, all 5 angles have the same measure. That means that each angle has to be 108 degrees. Now let's draw a diagonal as C. In fact, we can draw any diagonal. All diagonals are congruent to each other because of the multiple symmetries that regular pentagon has. Notice that triangle ABC is an isosceles triangle. So it means that the angles at the base should be the same. So this angle A and angle C should be, in this case, 36 degrees each. Now, whole angle C of the pentagon is 108 degrees. The top part is 36. It means that the bottom part has to be 72 degrees. Now notice that if we look at this angle of 72 degrees and look at the angle D right here, which is 108 degrees, together those two angles give us 180 degrees. Those two angles are what's called same side interior angles for AC and ED. And we know that same side interior angles equals to 180 degrees if and only if AC and AD are parallel to each other. Now let's draw a couple other diagonals. Again, all diagonals have the same length. And in this case, for the same reason, looking at the pentagon from a different angle, we find that AD will be parallel to side BC and EC will be parallel to the side AB. But now if you look at the quadrilateral ABCO, we find that AB is parallel to OC and BC is parallel to AO. And that means this quadrilateral is a parallelogram. In parallelogram, opposite sides have the same length. Since AB and BC are 1, it means that AO and OC are also 1. So in fact, ABCO is a rhombus. So now let's call this side AC with Greek letter phi. AD is also going to be phi, but one part is 1, so the other part, or D, will be phi minus 1. Now look at the triangle AOC and triangle EOD. Those triangles have two congruent angles. Angles O of both triangles are vertical, so they're congruent. And also, let's say angle A here and angle D here, they have to be congruent because they are what's called alternate interior angles for parallel lines AC and ED. And if these lines are parallel, alternate interior angles are congruent. And since these two triangles have two pairs of congruent angles, that means these triangles are similar. In similar triangles, ratio of respective sides should be the same. So the ratio of AO to OD should be the same as the ratio of AC to ED. Now, if we plug all the numbers we know for the sides, we get an equation for diagonal AC for phi. If we multiply this equation by denominator phi minus 1. We get the quadratic equation. We can solve this equation, get two answers. Now there are two answers, one with plus sign, one with minus sign, but only one of them is positive. Remember, we're not just solving quadratic equation, we are solving geometric problem. And in geometry, the side has to be positive. So the only acceptable answer is the one with the plus sign. But this number has a special name. This number called golden ratio. What we show the diagonal of a regular pentagon with the side 1 has a length equals the golden ratio. But we're here to calculate sines and cosines of different angles. So let's continue doing that. Let's clean up the picture. And next thing, notice that triangle ABC and triangle EDC are congruent to each other. And that's because regular pentagon has multiple symmetries. But that means that angle right here is also 36 degrees. But whole angle C is 108 degrees, so the angle in the middle is also 36. Now notice that triangle ACE is an isosceles triangle. AC and EC are diagonals and they're congruent to each other. So what we can do with this triangle is we can draw an altitude, CF. The altitude in an isosceles triangle is also side AE bisector. Point F is in the middle of that side. And also that line is angle C bisector. It means that this part is 18 degrees and this part of 18 degrees. And obviously this angle has to be 72 degrees, but we already actually talked about it before. But now what we have a triangle AFC, which is a right triangle. We know two sides. We know AC, which is phi, which is golden ratio. We also know AF, which is half. And from that we can calculate sine of 18 degrees. Sine is the ratio of the opposite leg to the hypotenuse. And that gives us this answer. But if you go online and look for sine of 18 degrees, you normally don't see this formula. And that's because many people don't like to have irrationality in denominator. So what they do, they divide and multiply this expression by a conjugate of the denominator, which is square root of 5 minus 1. And if you do, you get this answer. Now, cosine of 18 degrees could be obtained either from the fact that sine of an angle squared plus cosine of the same angle squared is always 1, or we can say that cosine of 18 degrees is the ratio of adjacent leg CF to the hypotenuse AC, and calculate CF from the Pythagorean theorem. Either way, you're going to get the same answer. Now, here we have an angle of 72 degrees in the same triangle. The difference between 18 and 72 degrees is whatever was adjacent leg for angle of 18 degrees would be opposite leg for angle of 72 degrees, and vice versa. So we get our sine of 72 degrees, which equals to cosine of 18 degrees, and cosine of 72 degrees, which equals to sine of 18 degrees. Next thing, we want to find sines and cosines for 36 and 54 degrees. Notice the triangle ABC already has an angle of 36 degrees. This triangle is an isosceles triangle. Let's drop an altitude here too. It will split angle B in two halves, each of them 54 degrees. And here we have it. Triangle BGC is a right triangle. We know two sides of this triangle. We have BC is 1, CG is phi over 2. And that gives us sine of 54 and cosine of 36. Now we can find BG from Pythagorean theorem and get cosine of 54 and sine of 36 degrees. And that's it. We found everything.